starts. Welcome back.
Hi, everybody.
Hey, we're going to do 1.4 today.
Alrighty.
All right, we're going to just build functions by adding, subtracting, multiplying, dividing, composing, inversing.
Cool.
That's it.
Some algebra stuff.
First, some more notational purposes.
Okay, so when we
Take us
say
away.
we are going to add functions, this is the notation you will see. Okay, and you need to understand that what does that notation mean? It means you're literally going to take the function f of x and you're going to add it to the function g of x.
That's it?
That's it. We just want you to understand the notation.
There's no extra x in there multiplied by something?
No,
Good.
not
Don't
at
do
all.
that.
Don't do that. Okay, when we take the function and we are subtracting it, we could say f minus g of x, or we could say f of x minus g of x. It means the same thing.
Sounds easy enough.
Okay, that's a minus, not an equals. All right, what about this one here, Mr. Lecky?
That looks like times. So how about f of x times g of x?
Absolutely. Now remember, f of x and g of x is the actual function. Okay, and then the last one's divide, so you probably figured this out by now. Divided by
Except for g of x can't be what?
0.
No zeros.
No zeros.
Or it doesn't work.
Alrighty, because it's
Easy enough.
division. All right, let's get some algebra stuff in here.
So we have two functions
Okay.
that we need to look at and tell the domain first.
Okay, we always want to consider the domain first. That's a great place to start. So f of x equals 6 minus x. What's the domain? Well, we had 3 domain rules the other day. We cannot,
No square root of negative numbers.
we cannot,
Divide by 0.
we cannot.
Take a logarithm of negatives or 0.
Okay, well, last time I checked 6 minus x doesn't any of those.
No. So all real numbers.
All real numbers. I'm going to write that with interval notation.
Fancy you.
I am. Okay, g of x now is a square root. And we said that we can't square root negative numbers, which means that x plus 2, again, would have to be greater than or equal to 0. X is greater than or equal to negative 2. If you wanted to do interval notation, rather, it would look like that. Okay? All right, so now we're going to go combine these. And we picked 2 of the types to combine for you. We thought it would be redundant to do all
Keep doing
4.
them all.
Yeah, so we're going to find g minus f of x. Again, what does that mean?
It means g of x
Yes?
minus f of x.
Yes, it does. Well, g of x is simply
Square root of x plus 2.
square root of x plus 2.
But now I have to be careful that I subtract all of f of x. So why don't we just go ahead and put parentheses around the entire function.
Parentheses, bracket, make a home.
6 minus x.
6 minus x. Okay.
And what
Anything
do we-
else we can do to that?
Well, we could distribute that negative sign now, which is why we put the parentheses around it.
Okay.
And there's our function.
Now, I have a lot of students ask me, is that it? Is there something else we should be writing? If you want to get technical and write down that this is g of x minus f of x, you can. Since we have hammered it into your brain that an equation or a function needs to have an
There you
equal
go.
sign. Okay, how about the domain of our new function,
Well,
Mr. Lecky?
again, we go back to our 3 rules. There's no logarithms, there's no division, but there is a square root, and inside the square root cannot be negative. So once again, x plus 2 cannot be, or has to be greater than or equal to 0, which means that the domain is negative 2 to infinity, including negative 2.
All right, so it's the same as the g of x domain.
Same as before.
Okay, so even though f of x was all real numbers, g of x sort of restricted us
Yep.
a little bit. Okay, second example, find f of x divided by g of x. I
Oh,
just
you just said what we're doing,
what we're doing here.
and there's nothing to do except for just replace them with the functions that were given.
Okay, so we've got 6 minus x over the square root of.
X plus 2.
Okay, now is this domain going to work the same way?
Basically, we're going to do the same idea. We start with our 3 rules,
Okay.
except for this time, our square root is in the denominator.
Oh, but we can't divide by 0.
No dividing by 0. So not only can x plus 2 has to be bigger than 0, but it can't be equal to 0 because it's in the denominator and not the numerator.
Exactly. So the square root is taken care of with the greater than or equal to 0 part, but we can't use the equal to 0 part because of the fraction.
And the numerator doesn't bother our domain at all in this problem. So x is greater than negative 2, which in interval notation is negative 2 to infinity. But notice the difference between the domains for a and b. Negative 2 is not included in part b because you cannot divide by 0.
Correct.
Very subtle differences. It's the difference between those people who really get it and those people that are trying to fake us out.
Well, and the hard part about pre-calculus is you have to remember all your algebra rules all the time.
All the time.
Be very diligent. And
All the time.
I promise you, if you practice these problems and you're diligent, then you will do the same.
But it takes a lot of practice.
Yeah, you'll do
Gotta
the
be
same
careful.
thing on a quiz or test. Okay, so we've added, subtracted, multiplied, divide. Let's talk about composites.
Composing functions means to put, really just to put one function inside of another one. That's really all it means.
Yep.
Instead of inputting a number, we're actually going to input an entire function
An entire function.
into another function.
So a minute ago, we had the square root of x plus 2. You can think of that as two functions.
Yep.
You can think of that as x plus 2 and the square root of something.
Correct.
Okay.
And so we literally inputted x plus 2.
Okay.
Now, there's this notation, it's called circle notation. It kind of spells fog, but it's f circle g of x. But it means to compose f with g. But that's kind of confusing.
It is very confusing.
So why don't we write it as f of g of x?
So all you're going to do is take the g of x and have that be the input of the f function.
What if we wrote it the other way?
Okay.
What if we wrote g circle f?
Then we would have to write, I got to write that down, g circle f, just in case we lost anybody here. Then we would be taking the f function and putting it inside the g.
Okay?
Okay, so the order does matter. Okay, it is not commutative.
No commutative.
No commutative. Okay, do you want to write anything yet?
Ah, you're doing a great job.
I'll save the hard one for him.
I'm trying not to talk over you. How's that?
You're doing great. All right, suppose f of x is 1 minus x squared, and g of x is the square root of x. So we're going to do exactly what Mr. Lucky just said. We're going to find g of f of x. Okay, so again, what does that mean?
It means we're going to plug in, first we're going to scribble out f of x. No, we're going to plug in the entire function of f everywhere there's an x in the function for g.
Okay, so what I'm going to do is I'm going to make a home for it. I like
Yeah.
to make a place for my guests to be.
Remember
Okay.
when we plugged in stuff earlier? We always had a parentheses where
We
x
did.
was, and we did even and odd, and when we did function notation,
Okay.
put a parentheses everywhere there was an x.
So we need the square root of something. Okay, and where we see that parentheses is where we're going to plug in our f of x. Marker works that way, which is 1 minus x squared. Now, should we do any simplifying to that, or are we good?
Well, the parentheses doesn't really matter in this problem, so we could just write it as the square root of 1 minus x squared, but we really can't simplify that because it's 1 minus x squared, and you can't
Yeah.
simplify them separately.
A square root and a square don't do anything when there's a big fat minus in the way. Okay, what about the domain?
Oh,
now?
this is going to be interesting. At some
Okay.
point in time, they're going to learn that this is really the equation of a circle later. But for now, let's stick with our 3 rules.
Okay,
We have a square root function. That's rule number 1.
okay,
We cannot have 1 minus x squared be a negative or, well, it just can't be negative. So 1 minus x squared has to be greater than or equal to 0.
correct. So we want to get the x squared by itself?
Get the x squared by itself.
I would do it that way.
That's fine. We just add x squared to both sides.
High
Now,
maintenance.
when we go to solve this inequality, we take the square root of both sides.
We do.
And this is where we get
little
a
tricky.
new rule, if you will, for some people. But it's the official math rule, okay? The square root of 1 is just 1.
Correct.
That's all there is to it. The inequality is not going to change because the square root function's increasing, and that's not going to change your inequality.
Well, it's
but
not going to equate. We didn't multiply or divide by negative either.
Correct.
Okay.
The
But
square
what's
root
the
of
square
x squared is mathematically, by definition, the absolute value of x.
Oh dear.
Okay? This is
Okay.
getting technical.
So from chapter P, we solved absolute values.
Absolutely. Now we have the absolute value of x is actually less than 1, less than or equal to 1.
Yeah. It looked like this.
So if we have absolute value, which was distance from 0, has to be
Correct.
less than or equal to 1.
That's where I stood up here and went like this and went like that.
Yeah, she had all kinds of weird
what I do.
animations. All right, so we
What
are
I do.
actually stuck between 1 and negative 1. So 1 on the right, negative 1 on the left. And there's nothing to solve because it's just simply an x. So our domain is actually from negative 1 to 1, including both. And that's the domain of our function.
Kind of weird.
All right, and
Fun
if you ever
stuff
graph
going on.
this, you'd actually see the top half of a circle.
And for right now,
With a
if you're
radius
not
of 1.
comfortable with domain, you can check your answer by graphing it.
Absolutely.
However, you probably won't get that calculator on the test, so
We're
don't
just gonna
rely on it.
Keep throwing these domain questions at
Okay.
you, though.
All right, so what about if we're finding f of g of x? Okay, now this has got to be backwards. Okay, so we're going to take our f function, make a home, so everywhere we see an x, 1 minus something squared,
So that's our f function, but instead of x, she wrote a parentheses.
okay, and we're going to replace it,
We're going to replace the inside the parentheses with what g of x equaled.
which is the square root of x. Any
Easy. That's all
simplifying?
we're doing. Well, we
simplifying
can
here?
square a square root of x, and we actually get
X.
x. So we end up with 1 minus x.
Okay,
Now here's the hard part. This is the part that makes this different from algebra 2, really.
absolutely.
Okay? 1 minus x as a function is a line. It
is.
has no issues with our 3 domain issues, does it?
It has none. So it would, we would
Our
have the
first
urge now to say all real numbers.
Absolutely. The problem is that we created this function with a function of g of x, which was a square root function, that had a limited domain.
The domain of g of x would be from 0 to infinity.
So since g of x had a limited domain, and we used it to create our new function, our new function has to work only for the limited domain that we had originally, which means this function f of g of x, which looks like 1 minus x could go on forever, actually has a limited domain from 0 to infinity because of the limitations on g.
That would be a great place to put a big star in your notes. It's something that's weird. You might want to ask us about that again in class.
Okay?
Okay?
All right.
Inverse functions.
Okay, you remember the vertical line test for functions?
I do.
You do?
I do.
Vertical line test said if we had a vertical line that hit the graph how many times?
More than once.
More than once, it wasn't a function.
Bad.
An inverse function just switches the x's and y's. So
Okay.
what happens when we switch a horizontal or a vertical line?
We get a horizontal line.
We get a horizontal line if we switch the x and y. So we're going to apply the horizontal line test to a function in the same way we applied the vertical line test in order to determine whether or not this function actually has an inverse that is also a function.
Okay.
So we're not actually finding the inverse yet.
We're not. We're just checking to see if the inverse will be a function.
Okay.
Okay. So there's a graph given. If you care, this is the function, okay, h of x. And I've drawn a horizontal line. Now we need to check it. So if we start at the top and work our way down, does it ever touch more than once?
Nope.
It does not. So it passes the horizontal line test. So now how do we give this answer so you know what we're talking about? Well, first rule number 1, never say it.
Bad.
Bad. Okay?
It's
It,
2
yes,
letters
and no
short
are,
of a bad word.
it, yes, and no are not good ways to start an answer to a question. Okay? So what do we want to say? Well, we want to say that this function, h of x, has an inverse. That's a function. Can I abbreviate?
Inverse
Okay.
funk.
Because why?
Because h of x passes the
Passes
HLT.
the horizontal line test.
Piece of
Okay?
cake.
That's it.
It's a sentence though.
Okay?
Answer in a sentence.
Let's go check our other one.
Ooh, this one's bad. It hits twice.
Bad, 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 bad. So that's the function name is k of x.
So k of x does not have an inverse function.
Because why?
Because it fails the
Not
horizontal.
it.
Haha. Because k of x fails. See, she corrected me. Don't say it.
All right.
We're going to
that's
go
it.
all grammar on you if you use it and make sure it refers to the proper pronoun.
We don't know what
proper
it
noun.
is.
Well, how do we go about actually finding inverse
Oh,
functions?
okay. So we just talked about whether or not it had one. Now we need to know, can we find it? Okay, well, you can find it graphically, you can find it numerically, and you can find it algebraically.
Those words are on the front cover of your book.
Okay, so
Well,
it's
I don't know if they
important to be
actually
able to
have seen their
do
book.
all, they are. All three. We need to focus algebraically, and you've done this, okay? So we're going to switch x and y.
All right,
There's
so
no
we
y.
start with replacing the f of x
There
with
we
y
go.
equals. Then we switch them.
Okay?
Everywhere the y is turns into an x, every x turns into a y, because it's all an inverse function does, is switch the domain and range of a function or switch the x and y coordinates.
Okay?
Now we just have to solve for the new y. We add 1 to both sides, and we take a cubed root of both sides. Make sure you do those in the correct order.
Okay?
And once you solve for your new y, you want to label this correctly. This y represents our inverse function, so it represents f inverse of x, or f with a little -1 where the exponent usually is, but don't ever use it as an exponent. It's f
Not.
inverse.
Yep. And you know, because it's in the middle of function notation.
All right, so we write the original, switch x and y, solve for the new y, label it correctly.
Relabel it. Okay, so now, that's pretty Algebra 2 level. Let's go on up a
bump it
notch to FST.
Kick it up a notch.
Pre-calc level. We need to be able to
Bam.
verify inverses. Okay, so what does verify mean?
Verify means to prove, and the only way to prove
Algebraically.
anything is to prove it algebraically
Yep.
using definitions and other things, but
Okay,
we have a definition for an inverse function.
so the definition of an inverse function says a function f of x has an inverse f inverse of x if and only if, that's important, f of f inverse of
So
x.
that means you plugged the inverse function into the original. That's a
Yep.
that's a
It's a
composition of those two
composition.
functions.
Yep. It has to equal x, and f inverse of f of x has to also equal x.
And that one, we actually plug the original function into
To
the
the
inverse.
Okay.
And then we have to answer or solve algebraically one step at a time. Again, it's a proof. Don't skip 4 steps and expect us to follow it.
Until
one
you
thing at a
get
time.
to x. Okay.
All right.
So you're not finding the same value as you're not finding equals. You're finding x. All right, so according to this definition, how many composites are we going to have to do?
We got to do 2. We got to plug the inverse into the original, and we got to plug the original into the inverse.
So the nice part about doing 2 is that you can't forget which way to do it because you have to do it both ways.
Yeah, exactly. You don't have to.
All right, so we've got our 2 functions written down here for you that we had from example 5, okay? So first let's check, let's do f of f inverse.
All right, so here what we're going to do is we're going to write the original function of f.
Okay,
Everywhere there was an x, we're going to leave a space or a home, if you will.
Something
Big parentheses. And inside that parentheses, we are going to replace it with the inverse function, the cubed root of x plus 1.
okay, now we need to just do some algebra.
And it is very important that you do one step at a time and you do the correct step. Because
Yes.
if you do the wrong algebraic step, it is an incorrect proof, even though you may come out with x again.
And just because you wrote x doesn't mean it really equaled x.
All right, so what is the correct thing to do in this problem first?
All right, well I see a cube root and I see a cubic.
So we
Those
should
two
do the
things are gonna
exponent
cancel.
first, and cubing a cubed root will cancel, and you end up with simply x plus 1.
Okay, now this minus 1 over here is still hanging out. We didn't touch him yet.
Notice we didn't do 2 steps at once, we did 1 step,
Okay, so if I have a plus 1 and a minus 1, those will go away.
and we simply get,
X.
which is what we want.
Okay, so far we have proven that f of f inverse of x is really just
So are we
x.
done?
We are half done. That one
Half
is
done.
correct. Now we need to go prove it the other way.
So
Okay.
now what we're going to do is we're going to write the inverse function, and everywhere there was an x in the inverse function, we're going to put a parentheses, and we're going to replace it with the function of the original function. So we write the cubed root of x plus 1, but instead of
Okay.
x we put a parentheses, and what are we putting in that parentheses?
We're going to put the original function x cubed minus 1.
There we go.
Okay. Now, order of operations, I can't do my exponent first, but the next step would then be parentheses.
And the parentheses is like what's really inside the cube root. So inside the cubed root, there's an x cubed minus 1, and those parentheses weren't necessary, but we put them there to help us out. But x cubed minus 1 plus 1 simplifies to simply,
I would probably just write this first, actually.
okay, you want to distribute the 1 in front of the parentheses.
I just got rid of the parentheses.
Fine.
Okay.
X cubed minus 1 plus 1 is simply
X cubed.
X cubed. And the cube root then of x cubed is
X.
x.
So what did we figure out?
We just
figured
showed
out
that the inverse of f of x is equal to x.
Okay. So we proved it forwards and backwards.
And now
If
let's
we want to get really
let's
fancy, we
write
can
a
put it all
fancy
together.
sentence. Therefore,
I should let you write this. You write 12 times faster than anybody on earth.
I don't know about anybody on earth.
How's that?
All right, so what does that tell me?
That tells me they're inverses.
There it tells me they're inverses. Okay, so
Okay.
so f and f inverse actually are inverses. Okay? And we are done with our proof. Now, that was fairly straightforward. Using some basic rules. Let's do one that's a little more complicated just because we
Can.
felt, well, we can, and I felt a little bad not putting it on the notes since
Well,
it's,
we wanted you to see a worked out example. This is definitely the hardest problem you'll have to do. Okay?
okay?
So we need to find f inverse, and then we need to verify that f and f inverse are inverses.
So finding, refresh my memory, what do we do?
We switch the x and y. So our function is f of x equals x plus 3.
So for right now, we're focused on finding.
Yep.
And so our original function is just going to be y equals x plus 3 over x minus 2.
All right.
Now we're going to switch the x's and y's.
We are.
You talk.
Okay. So we're going to have x equals, and then we're going to have y plus 3 divided by y minus 2. Okay. So now this is a fraction. Mr. Leckie, in chapter P, we did fractions. We multiplied by the least common denominator. There's only one denominator of y minus 2, so let's multiply both sides by y minus 2. This will get rid of our fractions for us, because we don't really love them. Okay? So now you have x times y minus 2 equals y plus 3. So what are we going to do with that?
Well, we're trying to solve for y.
Yeah, we got y's on both sides.
So let's go ahead and distribute the x.
Okay, that'll at least get rid of our parentheses. So now xy minus 2x is going to equal y plus 3. But we still have y's on opposite sides.
And so when we have variables on two different sides, we'd like to put them on the same side.
We would.
Which side would you like them on?
The left.
So we're going to subtract the y from the right side.
Which means we want everything else on the other side.
So we're going to move this 2x to the
Okay,
other side
so
by
how about
adding it.
2x plus 3.
And there's a positive 3 over there already.
Okay, well the good news is the y's are on the same side. The bad news is there's still more than one y, and we cannot add them together because they're not like terms. Any ideas?
How about we factor out a y?
Ooh, let's factor. What's the greatest common factor of y? So x minus 1 would be left over, and 2x plus 3. And now we can divide by the factor of x minus 1 so that the y is actually by itself. So 2x plus 3 over x minus 1. Let's go back and rewrite that with our function notation. So f inverse of x will equal 2x plus 3 over, I don't know, I can't see, x minus 1. And there you go. So the trick to that problem is definitely that you're going to have to do a GCF. Okay, we found it. Now we need to verify.
Hey, you notice on your notes you have a whole page?
Yeah, get a new page.
You're going to need some more page. So here's the deal. We have f of x was x plus 3 over, what was it, x plus 2? X minus 2. And f inverse of x was 2x plus 3 over x minus 1,
Yes.
correct?
Yes, it was.
So now what we're going to do is we're going to verify.
Okay, so 2 steps.
First step, we want to show that f of f inverse of x equals x. That's what
Okay,
we want.
so take the inverse, plug it into your original function.
Which means,
So everywhere you see an x in the f of x function, you're going to leave a little space or parenthesis to make a home for the new expression. Okay, what are you going to plug in there?
well, we're going to plug in f inverse, which is this entire mess.
Ew.
So it's going to be 2x plus 3 over x minus 1. Everywhere there was an x in the original function.
That's a lot of fractions, Mr. Lecky.
I love fractions. Okay, so let's take over here. In order to add or subtract these before we can divide them,
Okay.
we need to get common denominators in
We
order
do.
to add or subtract. So the denominator on this 3 is a 1.
Okay.
The denominator over here was x minus 1.
Let's use x minus 1 as a common denominator.
So I'm going to multiply the bottom of this by x minus 1 and the top by x minus 1.
Okay.
So that in my numerator, I have a denominator of x minus 1. Try saying that at dinner time.
Okay. I get it. I get it. You got a least common denominator of x minus 1. Okay?
So I didn't do anything to this one, did I?
You didn't. So we still have 2x plus 3
2x plus 3, and then there's a plus 3 times x minus 1 on the top.
Okay, I think I get it. Let me see if we can do it on the bottom. So we're
Do
going
the
to
same thing.
multiply the top and bottom of the 2 by x minus 1.
Same denominators right here.
Okay? So then the new denominator on our new denominator is x minus 1. And on the numerator, we're going to have the 2x plus 3 that was there minus 2 times the x minus 1 that we put in.
All right.
Okay, can we clean up our numerators a little
Let's
bit?
clean this up, shall we?
Okay.
All right, so
You
here's
might want to go way over there.
way over there.
need
She's
more room.
kicking me out. All right, so here's the deal. Here's
we go.
our fraction bar.
Okay,
In the numerator, we have x minus 1.
we do.
We have a 2x plus 3.
Yes? Plus
If
a
we distribute the
3x minus
3, we get 3x minus 3.
Okay,
In the denominator, we also have x minus 1 in the denominator.
okay. We have 2x plus 3
2x plus 3 minus 2x plus 2.
Okay.
Okay, now let's clean this up. What does
How about-
2x plus 3x minus 3 make?
5x.
5x over x minus 1
Well, that's better.
divided by,
Well, the x's cancel, so 5.
this cancels with this, and we get 5
Over x
over
minus 1.
x minus 1. Now,
How do we divide fractions by fractions?
well, the long way to do this is to multiply by their reciprocal.
Correct.
Okay, so again, if you wanted to do this, you could come over here and say, okay, this is 5x over x minus 1 times the reciprocal, which would be x minus 1 over 5. But what happens to the x minus 1s
Oh,
when you do
they
that?
cancel.
They cancel. So when you're dividing two fractions like you are here, and their denominators are the same, can we just go like that?
Denominators are going to cancel, so we'll have 5x over 5,
So either way we do it, we end up with 5x on the top and 5 on the bottom,
which is x.
which the 5's then cancel, and we're left with x.
Phew.
Now, that was, what was all that? That was f of f
F
inverse of x equaled x. So are we done?
No, because we have to do 2 of them. Now it's only 1 of them.
That's
Okay,
only
more
one
paper.
direction. Let's have a new page. You probably got room on your paper to do this. Let's see here. Can I copy any of these things?
I could just tell you what they are.
Okay, that's perfect.
Okay, so f of x
You have them on the top.
was x plus 3 over x minus 2. And f inverse was 2x plus 3 over x minus 1.
Now
And
we
now
have to go,
do f inverse of f of x. Put the original inside the inverse.
which means we're going to write this function, and everywhere there's an x, we're going to put a parentheses.
Correct. There's an extra 2 there that's kind of different.
What do we put in there?
X plus 3 over x minus 2.
We put in all of that mess.
It's your problem.
Woohoo, this is fun.
I
All right.
didn't correct you guys. Okay, so if we learned anything from last time, it was to multiply the top and bottom of that 3 by x minus 2.
All right.
Okay, so in the top of the top, we're going to have 2x minus, yeah, what he said.
We end up with the denominator of x minus 2.
Yes.
We have 2, which is over 1, by the way, times x plus 3.
Yes.
Plus 3 times x minus 2.
Correct.
In the other one, we have this is over 1, so we multiply the bottom and top by x minus 2, so that it matches this one.
So on the denominator we'll have x minus 2. And on the top we're going to have x plus 3. Minus 1
This is
times
important.
x minus 2. Now we just have to clean up our top of our top and our top of our bottom.
So there's the fraction bar of the whole thing.
Okay? So
In
on
the
top we're
numerator,
gonna
we have x minus 2. And we have 2x plus 6
plus 3x
x.
minus 6.
And down here we have x minus 2. And
X
we have
minus 3.
x plus 3
Thank you.
minus x plus 2. Now, can we go ahead and just cancel these because they're the
Yes,
same?
please.
Is that too many steps to do at
No,
once?
that's
I can
okay.
handle that. And what does this make?
That's going to make 5x.
And what is this going to make?
5.
And what is 5x over 5?
It's x.
So, therefore, f inverse of x equaled x, which was also f inverse of x. So, f of x and f inverse of x
Are inverses.
inverses. Yes! We're done.